at the planer. This single walnut board I picked up was pretty straight and flat to begin with, so skip planing it is all that was really needed. There was no need to joint any one of the faces. I really just wanted to get a better look at the grain before I started locating pieces. And with the beautiful walnut grain exposed, I laid out for my rough cuts. Now this box is a square, so all I needed here is 4 equal length sides with as few defects as possible. Rough cross cutting is done at the miter saw, and I typically leave 1/2 of an inch to 1 inch of extra length here. Back to the planer to plane down to final thickness of just 5/8 of an inch. Here you can see my technique for drastically reducing planer snipe. Each board is pushed through without any gaps, and the first board is rotated into the lineup to also be the last board through. And with this rotation technique, you can nearly eliminate snipe on smaller pieces, but an even better technique would be to use a sacrificial board for the first and the last piece. With the machine in jointer mode, one narrow face is flattened square to either wide face, and it's best to do the narrow face jointing after both wide faces have been planed, so that you have you have direction options and you're not forced to cut uphill. The final width is established at the table saw, and the final length is also established at the table saw with 2 cuts on a crosscut sled. For precise cuts like this, I prefer to use the crosscut sled versus my miter saw, because my miter saw it's developed quite a bit of slop over the years. It's definitely not as accurate as it once was. With all these sides at their final dimensions, I can get a better idea of the grain appearance, and now I can determine what pieces will go where. The recipient requested proud through dovetails for the box. The process starts with a marking gauge set to 3/4 of an inch, and the material thickness, like I said, is 5/8 of an inch, so after assembly, the pins and tails, they should be 1/8 of an inch proud of the side surface. I like to cut the tails first, and to save some time, I clamped both tailboards together to be cut together. A pair of dividers makes layout extremely easy for dovetails. There's no math required, and if you've never used them before, the process is really easy. I have an older video explaining the process of using dividers, and I'll have a link to that in the description if you're interested in checking it out. Speaking of a link in the description, I'll also have a few more links to some of the tools that I'm using in this video. They're all affiliate links, and they're all for other small businesses like mine. So if you buy through them, just know that you are supporting not only my small business, but other small businesses as well. Very much appreciated. First up is this magnetic dovetail guide. This is the Cat's Moses magnetic dovetail guide, and it's really the best one that I've used. The top section of the guide has 4 different faces with magnets embedded in them, and it's worth noting that these magnets were recently upgraded on a very minor recent redesign of the magnetic dovetail guide. And when cutting the tails, the post keeps the saw teeth running perpendicular to the wide face of the board, and the magnets keep the saw itself tilted in the appropriate angle for the tail cuts. I like to use this inexpensive fret saw or jeweler's saw to remove the bulk of the waste. The closer you get to the marking gauge lines, the less work you have to do with the chisels, but you also risk going past the line if you're not too careful. So it's kind of a slippery slope there. I sometimes accidentally go too far, so I tried to err on the side of caution with this one. On the sides of the tail boards is the half pin that needs to be cut off. There's a dedicated 90-degree face on the magnetic guide for this very reason, and just line up the outside of the saw teeth with the waist side of the marking line and make the cut. Simple and precise. The front tailboard needs to be cut down by 1/2 of an inch to allow room for the 1/2 inch thick sliding lid, and I chose to do this after cutting the tails just to make the process a little bit less complicated. Here you can see the slightly shorter front board in place. Now the waist on the tailboards can be removed, and I like to make multiple chops back to the marking gauge line and only cut halfway through from either side. You don't want to cut all the way through from one side of the board because you risk blowing out the other side that you kind of can't see. I also like to lean the chisel slightly so that a slight undercut is made on the shoulder surface. A slight undercut, it's not going to have any structural changes, but it's going to guarantee that there are no high spots to obstruct the joint from closing properly. If needed, the inside corners are cleaned up with the board vertical in a vise. After all of the tails are cleaned up, the geometry can be traced onto the pin boards, and the easiest way to line up the boards is to set the pin board in a vise at the same height as something like a hand plane. Then use that same hand plane to elevate the other side of the tailboard, line up the shoulder of the tail cuts with the inside edge of the pin board, hold it down firmly, and gently trace the tails with a marking knife. The harder you press with the marking knife, the more likely you are to go off track. So a couple consecutive light passes with the knife, that's all that's needed. Just like with the tail cuts, the magnetic guide does the majority of the work. All you need to do is make sure that 100% of the saw teeth are on the waste side of the cut, and the edge of the saw teeth is touching the waste side of the marking knife line. That's important. For the pin cuts, the guide keeps the saw blade perpendicular to the end grain face and rotated about the same degree, well, exactly the same degree as the tails. Once again, the fret saw removes the bulk of the waste, and the chisels refine the shoulder to complete the pin boards. When it comes to a fitting or a dry assembly, there really should be no necessary adjustments so long as you cut on the right side of the line every single time. That's one of the benefits of using a magnetic guide like this. It's the same thing as using any type of jig on the table saw. It's repetition, it is precise, accurate results. All you have to do is place it in the right spot every single time. The first dry fit should be a nice, satisfying assembly. Next up is the bottom panel dados and the sliding lid dados, and for that I decided to use a 1/8 of an inch diameter bit on the CNC machine. The bottom panel I chose was about 3/16 of an inch thick, so a single pass with a 1/4 of an inch diameter bit at the router table, it would be too wide, and a couple passes with a 1/8 of an inch bit on the router table would increase the opportunity for me to make some dumb mistake and screw it up. And also, it was a really quick process to mount all 4 pieces, program the cut in V-carve, and just watch the precision happen. A CNC machine is the most versatile and capable tool in a modern woodworking shop. The plywood bottom panel is cut to size, and a test fit confirms that it fits. For the lid, I had one wider piece of walnut in the scrap bin that was really close to the size that I needed, so I planed it down to final thickness, squared it up at the table saw, and then sized it to the width of the lid opening. A rabbet is needed on 3 sides of the lid to match the dados in the box, and to make these I used a 1/4 of an inch bit in the router table and made tiny adjustments to both the bit height and the fence position until I got a rough fit for the lid. It's just the fastest and easiest way to keep making slight little adjustments to size something, or size the rabbet to the dados. I sized it a little tight at this point so that I could get a perfect fit with a hand plane after assembly. With the lid at its final size, a personal touch can be cut into the top surface of the lid, and for this a 90-degree V-bit was loaded into the CNC machine and the design was cut. Without a finish though, it's kind of hard to see the design right off the machine. It really pops after the finish is applied. It turned out great. And while I was already there at the CNC, it was just convenient to go ahead and shape the integrated handle while I was at it. Finally, the box is ready to be sanded, and it's much easier to get all of the inside surfaces and all of the tails and pins sanded before assembly. Of course, making sure not to remove too much material on the inside faces, as that would negatively affect the fit of the joints. For the assembly, I chose to use epoxy for its slow setting characteristics, and also because it dries clear. It won't stand out like a sore thumb if some of the material did squeeze out just a little bit, and because the fit was also really tight already without any glue, I only applied the epoxy to the inside, I say 1/4 or 1/3 of the pins. This little amount of epoxy combined with the mechanical connection of the joint, it's going to be plenty strong enough to keep this box together long term. This isn't something like a dining table that's going to see a lot of abuse. I tried a new finish on this piece. I wanted something that was natural and something that was easy to apply, something that would feel as close to bare wood as possible, but still offer some protection from the oils of hands. This is a simple wipe-on oil wax mix. Wipe it on, let it sit for 15 minutes or so, and then wipe the excess off. And this project is done. There's not really much else to say. This project was for a family that had to experience an unfortunate event. I was given the interior size needed, the joinery type, the wood color, and a request to personalize the lid. I think that all the requests were met. Something like this, for me, it's a really good feeling being able to complete a task like this and offer some type of positivity to somebody else. And I hope that this box is something that can offer some type of peace.